And we are live. Hey, everyone. Thank you so much for joining our LinkedIn live stream today. I'm Gilberto Hernandez, lead developer advocate here at Snowflake. And I'm going to be your host for today's show. I'm super excited because we're going to be talking about something that I've seen a lot of interest in from the community. I see a lot of LinkedIn posts about this, questions, comments, that kind of thing. Really fruitful discussions that I see in our community. So we're going to be talking about all things interoperability and lakehouses. So using open standards and open protocols to build and power interoperable lakehouses. And I'm excited because we're joined by a couple of folks across two different companies, Snowflake and Microsoft. And I'm going to give them an opportunity to introduce themselves in just a bit. But we have quite a bit to cover, and I want to get right into it. So I'll first hand it off to Jimin. Maybe you can give us a little bit of an intro on yourself.
Yeah. Hi, everyone. My name is Jimin Sim. I'm a product manager at Snowflake, and I focus on the catalog ecosystem inside Snowflake.
Thank you. Go ahead, Kevin.
Thanks. Yeah, thanks for having me. I'm Kevin Liu. I work at Microsoft OneLake as a software engineer. I also work in the open source and with Apache Iceberg as an Iceberg committer.
Excellent. Thank you. And thank you so much for being here today. Thank you both of you. So like I said, we have a packed agenda. We have a lot to cover. So I want to just dive right into it. I mentioned this earlier, but I see a lot of questions around how to build interoperable lake houses. So typically I'll see questions on catalogs, catalog integrations, new features in Snowflake that enable this, and then just generally like how to get up to speed in building these type of architectures. So what I'd like to do is maybe just set the stage a little bit and give folks some context on kind of the space right now. And I'll start with a few questions for Jimin. And I'm curious, as we think about and see builders who are trying to build these architectures, what kind of patterns are you seeing as they try to build interoperable lake houses? What kind of things do they need? What are they asking for? That kind of thing.
Yeah, I would say the number one goal I see from builders is to eliminate data movement and duplications. They want to load data once and then allow multiple compute engines to access and query that data. And that is a single source of truth, and it remains in one place. So that's the number one goal I've seen. The other one is standardizing around open table formats like Apache Iceberg, which removes proprietary lock-in, and that really enables vendor flexibility, which I've seen folks enjoy. And lastly, the bi-directional data production. So initially, we might have started with loading data into the data warehouse, but now they want the ability for engines like Snowflake to run complex transformations and write these curated data back to the external lake.
Yeah. Awesome. And I love to hear that. I love that builders have that freedom and flexibility to build as the way that their architecture demands. Kevin, I'm curious, kind of like from your perspective, does this resonate with what you're seeing as well, especially as builders think about building with these open standards and open protocols?
Yeah, I think 100%. With the rise of data lakes, a lot of data is put on object storage, and then open table formats kind of organize those data into something that is open, which means as customers you're able to use whatever engine that you pick. In this case, we're using Iceberg tables as the format. Iceberg table itself has the concept of a catalog, which you interact with, and you can bring this catalog with you wherever you go, to different platforms, to different engine. So that really resonates with what we're building on Microsoft side, right? We're building a unified data lake. We expose Iceberg tables and Delta tables, and we expose that as a catalog. So bringing this catalog to you to say Snowflake, it is zero copy at the end of the day, and it's interoperable.
Super cool. I love to see this. And I mean, to that end, I know that Jimin, your team here at Snowflake, is working on a lot of new features to enable this as folks build out their architecture. So I'm really excited to talk about a new object, or what feels like a new object, basically in Snowflake, to enable this. And I've seen a lot of questions around this on LinkedIn and on Reddit. So I wanted to dive a little bit deeper into it. I'm referring to catalog linked databases in Snowflake. And so I'm wondering if you can just quickly give us an overview of catalog linked databases. So basically, what are they and how do they work?
Yeah, and I'm so excited to talk to y'all about catalog linked databases. We colloquially also call them CLD, so that might slip here and there. But it is a new Snowflake database object that is actively connected to an external Apache Iceberg REST catalog. So think AWS Glue, Unity, Microsoft OneLake, or a custom Iceberg catalog. And how it works is it automatically and periodically syncs with the external catalog. And the auto discovery process detects any new or dropped namespaces or tables registered with your external catalog, and then it picks it up automatically. Yeah, and it uses two components that already exist within Snowflake: catalog integration and catalog vended credentials.
Yes, this is awesome. We see that your cat is also very excited about CODs. CODs are one of my favorite new features in Snowflake. Just the ability to be able to auto discover and refresh based on the remote catalog, I think, is pretty neat. Um, Now we've seen features out there in the wild that they allow reads from externally managed Iceberg tables. CODs do this, but I think you mentioned they also enable writes. Is that correct?
Yes, yes, and that's one of the most critical feature differentiator, I would say. Previously, externally managed Iceberg tables were limited to read-only operations, but now we support full DML and DDL operations. So that includes insert, update, delete, merge on these externally managed Iceberg tables.
Awesome. Yeah, that's great to hear. And then I know you want to take us deeper into these features in a deck just shortly. But before we get to that, just one last thing. I'm curious, how does Snowflake enforce governance on these catalog linked databases?
Yeah, so once these tables have been discovered and created in Snowflake, it functions as any other first-class table object within Snowflake. So this means you get full, powerful native governance policy. So tagging, masking policies, row policies, they can all be added directly to these tables.
Very cool. I love that. All right, so I mentioned um, you're going to take us a little bit deeper into exactly how catalog link databases work in Snowflake and also rights to externally managed Iceberg tables. So I'm going to hand it over to Jimin for a few minutes so that you can cover these in more detail. So Jimin, take it away.
I think you're muted.
Okay, great call out. I was just saying, now let's take everything that we've talked about, the shift to interoperability, the necessity of Iceberg, and the power of catalog linked databases, and kind of see the bigger picture. So here, this illustrates that the necessity for openness. The data can come from any data source, and it's really spread across any location. And it's managed often by different teams and different catalogs. And this could lead to slow, costly data movement and unreliable governance. Our goal is to enable secure interoperability and allow any tool, Snowflake, Flink, Spark, to work against the data, regardless of the location or the tool that created it. And we also need to power AI, agentic workflows, and real-time dashboards with a single, governed, consistent source of truth. And this demands a new open lakehouse. And flipping over to the next slide. And I mentioned briefly the right to externally manage Iceberg tables, super exciting feature, enabling full DDL and DML capabilities. So why would you need it? This allows you to effortlessly connect, transform, and optimize your external Iceberg tables. You can use Snowflake as a high-performance transformation engine for the entire lakehouse, ensuring consistency for every other tool in your ecosystem. And when Snowflake writes to the external catalog, it maintains the transactional integrity and governance context that Horizon provides. How to use it? It's really simple. You can integrate REST Catalog to Snowflake, and it'll be ready to be read and written. All right, the last slide I'll present, extend Snowflake to your Iceberg ecosystem. And this shows a core architecture piece that makes this all possible, catalog-linked databases. As I had previously mentioned, it's a new type of database. It's really easy to set up. The command is written here, the create database, and you just need to specify the catalog integration object as part of the catalog parameter. And the core benefit is the ability to discover, read from, and write to Iceberg tables from anywhere. You can securely extend Snowflake's performance to your entire Iceberg ecosystem for simplified data management across your lakehouse. And that's it for me.
Awesome. Thank you so much for walking us through that. And folks, I just want to call out, as you have questions on what we're discussing, please drop them into the comments. And towards the end, we're going to have some time to go through a few questions that we can discuss here. So thanks again, Jimin. And I want to switch over to Kevin. Kevin, I think you have a little bit of experience using these new catalog link databases, right? So I'm going to hand it over to Kevin. And what Kevin's going to do is Kevin's going to walk us through a demo. And maybe before you go into it, Kevin, you can kind of set the stage and give us an overview of what you're going to cover, and then
Sure.
take it away.
Sure. Yeah. Let me share my screen real quick. Great. So what I'm going to cover, thank you, Jimin, by the way, for setting the context. First of all, I think as an open source developer, as a someone in the Iceberg community, I really appreciate how much effort you guys as Snowflake has put in to make the ecosystem more open. I think catalog link database is a great feature, just to make the Snowflake engine interoperable with all of the Iceberg tables out there. And this is where the story begins for us. So I work at OneLake, Microsoft OneLake, which is part of the Fabric platform. And think of it as a data platform. We recently released the OneLake table API, as you can see on screen. You can this is public documentation. You can go take a look. And what this is on the Fabric platform through OneLake, we released a set of REST API endpoints that is part of the standard, part of the Apache Iceberg REST API standard. And we exposed this to the outside world for interoperability, for other engines to interoperate with OneLake and read Iceberg tables from our platform. Right, so we expose this. It is part of the public standard. You can use any open source tool, Sparks, DuckDB, PyIceberg to read this, and everything works as is. Right, so we are coding against this open standard, and this is the specification right here. Anyone can go and implement their own REST API. It is very much open and available. And the good thing about this is we have a partnership at Microsoft with Snowflake, and we wanted to expose our data and make it interoperable with the Snowflake engine. The partnership is between the two platforms, so the idea is, any data that you have in at Microsoft, at OneLake, in Fabric is available in Snowflake, and vice versa. And we've done this through the open standard and the Iceberg REST Catalog. Right, so this is where the catalog link database comes in. So we, on the OneLake side, expose the REST endpoint, and Snowflake, using the catalog link database, can read and can interact with this endpoint, read from it, and get data from our platform. So I'll go through some of this, but these are the docs right here, and you can take a look. But let's do it live. So I have
we love live demos. Yeah, let's dive into it.
Well, it's kind of live. I took away the secret, so it's already run for you. But let's go through the SQL statements. So what I have here is a Snowflake account. It's my test account, and I want to integrate our OneLake Iceberg table API with the Snowflake catalog link database. So you can see, I refresh the state, and this is the important piece, right? In order to create a catalog link database, I need two things. One is the catalog integration. You can think of it as setting up a way to interact with an external catalog. And over here is, all the SQL statements necessary. And what I want to call out here is that this is, again, the open standard. right? We're coding against the open standard on the OneLake side, and Snowflake is accepting the open standard on their side. So all we really need to do is to fill out where the catalog is located. In this case, is onelake.table.fabric.microsoft.com/iceberg. That's where we host our Iceberg REST Catalog server. We specify which catalog you're interacting with, because there are many different catalogs as part of our platform. You then need a set of keys, right? We use OAuth, the standard auth for authentication. Microsoft has Entra. We are using, a OAuth client secret, and then we scope it to Azure storage. So these are all concepts within Microsoft and Azure, but the call out here is that everything is open standard, right? OAuth is open standard. Iceberg REST Catalog is open standard. I'm not going to run this because I took away the secret, but it's already run. And what you can do here is you can run this verify catalog integration statement. And it tells you, okay, you've done a good job. I can also list from my catalog, right? The catalog, you list from it. This is a system command. So, it tells you all of the namespaces in there. I can list my Iceberg tables. And, in this namespace, I have another Iceberg table. I'm going to pause here for a bit and go on to the other side where, the Fabric and OneLake platform is at. So this is the UI for Fabric. I can go into a lakehouse, which is basically our concept of a catalog. And you can see that previously when I list the namespace, these were all the namespaces that are listed. These are all namespaces inside OneLake. And inside those namespaces, you have tables. And this is, data that's already in OneLake. So what I can do is, I can preview this table on the OneLake side. It shows you, the data that's available. It shows you all of the schema of the table. I don't know if I have to refresh or not, but it should show up soon. Yeah, okay, it's 1,000 rows. But yes, so here's all your data. I'm reading this from Fabric, right? This is the OneLake side. But what I can do is I can also read it from Snowflake, the same data, no copy. Everything works off of open standard, off of Iceberg and REST Catalog. So I already created a catalog integration, right? Everything works. What I need to do now is create a external volume. This allows Snowflake to read from OneLake. This is already done. I can verify it. It's true. I can describe it. Great. So we have the two pieces we need to create a catalog link database, right? And this is how I can do it. Basically, it says, give me a catalog integration and an external volume. I already done this. I'm not going to replace it. You can see that it's running in the background constantly. And what I can do is I can say, okay, I want to interact with this catalog link database. I can show the schemas. Again, you can see these schemas are the ones that are perfectly matching these. And that's the point, is that the metadata is synced. And then same thing for tables. I can see my table over here and my table over here. I can now read from it directly. And this is powered by Iceberg and Iceberg REST Catalog in the background. I'm just going to read one. I mean, I can read 10, 1,000, whatever. Like I can read all of the data I want. And the UI is super nice here. I can count, right? The same amount should be on the other side. I'm just interacting with the data, zero copy. I can describe the table, right? It's the same schema as before. And then yeah, just testing what information it has over here. But yeah, I think this is just to show like, hey, like this table that's available here, it's all in object storage, it's all in Iceberg format, and with any engine, I can read from it. Either it's Snowflake or any of the Fabric engine, your data is available. And then I'm just going to show you that, hey, like this is everything works from the open standard. I have a notebook here. I'm using PyIceberg, which is like the Python client. Same thing. I'm using the same API endpoints. I'm using the same warehouse name. the same external volume integration, and I can list the same tables, and I can read from the same tables, and everything just work as is. Yeah, that's the end of the demo. I think if you're interested to learn more, we have docs on the OneLake table API side. We have docs on the REST catalog, and we have docs on the catalog link integration.
Thank you so much, Kevin. It's always a great feeling when live demos work perfectly. So that was great. Thank you for showing us both aspects, you operating in OneLake and also Snowflake, and working directly with Iceberg. So that was pretty neat. We have a few questions that came in from the community here, and I want to dive into that just kind of as we round out the show here. So I have a question here from SurveyWeb. The question is, does Snowflake offer its own Iceberg catalog? Jima, do you want
Yes.
to take a pass at this?
Yes, we do offer our own Iceberg catalog. It's called Horizon. And what's good about the Horizon catalog is that you can really take advantage of the full Snowflake platform support. So if you want to leverage Iceberg tables, but are also also care about business continuity, disaster recovery, those sort of features will only be supported with Horizon Catalog because we manage the metadata and we can manage the replication of those objects. So we do, and it's called Horizon Catalog.
Awesome. And we'll drop some links to some of the pages in the docs where you can learn more. Again, folks, this is going to go up on our Snowflake Developers YouTube channel, and it's also going to be on LinkedIn. So you can revisit this, you can rewatch it, and then you'll have access to the links to the docs pages that we'll drop in as well. So thank you for your question, SurveyWeb. So we have another question here from Srinivasan. So how do costs work for Iceberg tables? And I can take a pass at this. So you are going to use an external volume for your Iceberg table. So there's no storage costs within Snowflake for your Iceberg tables. Now, one thing to keep in mind is that if your external volume and your Snowflake account are in different regions, there are some costs associated with querying those tables. So I'm going to, you can find the details in the docs. I'm going to drop the docs page that you can read for more information and has a specific link that you can go and check out billing on this kind of aspect. But yeah, high level, as far as storage is concerned, no storage costs incurred in Snowflake. Okay. Let's see. Before we get into some more questions here from the community, I know that one concept that builders tend to kind of want to learn more about is this aspect of auto refreshing and auto discovery with catalog linked databases. So I'm curious, what is the difference between these two? So auto refreshing and auto discovering, and how do they work?
Yeah, I would say it's primarily a difference of finding a table and updating the data within the table. So auto discovery handles that finding the table piece. It's where we pull the external Iceberg catalog to find any new tables or schema changes made by any engine. And then auto refresh is where we update the latest data snapshot. So if any rows were added, then we pick up those changes that happened within the table.
Awesome. Cool. And one more, and I think Jimin or Kevin, both of you, feel free to take a pass at this one. But I also see questions around the remote catalog, and so maybe we can cover for folks what happens in the remote catalog if I drop a table inside of my catalog link database.
Yeah, I can take a pass at this.
Sure.
It's governed entirely mostly by catalog linked databases write permission setting. So if a catalog linked database is read only, and you can set the allowed write operations parameter to none, and that just removes a local reference to that table inside Snowflake. But if the catalog linked database is writable, then dropping that table inside Snowflake also causes that drop to happen in the external remote Iceberg catalog as well.
Yeah, awesome. So full read and write capabilities here, which is pretty neat. All right, so we are about to wrap up. I do want to call out a few things before we close out here, and maybe we can just quickly pull up. Yeah, so I'd like to invite everyone here to join us in November for Snowflake Build. If you like sessions like this, if you want to hear more product announcements, join more technical deep dives, and do some hands-on labs, Snowflake Build is our free virtual developer conference. It's happening globally from November 4th through November 7th. Here's a QR code that you can use to access the registration page and sign up and register. We're also going to drop a link shortly into the comments where you can use your browser rather if you want to register there that way. But as I mentioned, my favorite part is that it's free, and you can access any session. One new thing that I want to call out that's being done this year is if you attend 5 sessions at Snowflake Build, you'll get a voucher to complete the Snowflake Data Professional Certification on Coursera. And that is a certification that is made up of 3 courses of spanning modern data engineering with Snowflake. And that's actually a 20-hour course. So if you go to 5 sessions at Build, you'll get a voucher to be able to enroll in that and take the entire 20 hours worth of content. We're also going to close out with a few CTAs here. So I think we've already dropped one of the links here, which is a quick start. If you want to try out building out lakehouses and try out interoperability, there's a quick start that my colleague here, Conway, has already dropped to the comments. It's how to build a data lake using Apache Iceberg and AWS Glue with Snowflake. So check that out. And as I mentioned earlier, we're going to have links to all of the resources that we called out today, the pages in the docs. Obviously, the quick start is already here, and build registration in the comment thread here for the LinkedIn live stream. So before we close out, just want to say thank you so much, Jimin and Kevin, for coming onto today's live stream and showing really builders what we're doing in this space as we build with open standards and open protocols, and how this is all enabling interoperable lakehouses. So thank you so much, and we'll see you next time.